All right, so good afternoon once again, everyone, and welcome to session 9 of this program. This is the 5th week, and we're moving so fast. We're actually making a lot of progress. So we've looked at everything that's to do with Python. We introduced numpy in the last class, so we kind of brushed over numpy. We looked at how we can create arrays and some other things as regarding numpy. So we're going to continue and wrap up with numpy today. So that's where we're going to pick up from today. So can someone just tell us on the live class where exactly we stopped in the class on numpy last week? All right. I can sense that we don't have a lot of persons in this class. I don't know if it's because of the Easter holiday, but the attendance is not encouraging at all. Okay, so let me share my screen. By the way, this class, anyway, it's going to be a 2 hours class, right? But once we are done with numpy, we're going to end the class. But before I proceed, class rep and assistant, is there anything that I missed that I needed to speak on, or is there anything that you need to bring up to my attention?
No, sir. Good afternoon, sir. You've said everything, sir.
All right.
Yeah, thank you so much.
Hello, good evening, sir.
Yeah, good evening, Nigeria.
Okay, thank you so much for the admonition and clarification on a lot. Just like a quick thing to every one of us, just simply encouraging us to be more responsible and really to read guidelines and instructions. And we're very open to complaints, but exactly how you told us, there's a way to do all of this. Like the way you said, we're all adults and professionals as it should be. Any issue at all, we can always table it, but there's a way to do this thing. So we should just be more professional and more appropriate with all our complaints and everything. Thank you so much for the patience and everything, sir.
All right, thank you very much, Nigeria. You both have been doing very, very well. And just keep it up. So thank you for making the class run smoothly in my absence. And yeah, I believe you would even do much better. So yeah, in the last class we looked at several things in numpy. So let me zoom in the screen. Yeah. All right, so we looked at okay, so far we looked at what numpy is, right? We've also looked at numpy arrays, what numpy arrays are, and we've looked at how we can create numpy arrays. Right? We've looked at the different attributes of numpy arrays, the shape, the size, the ending. So we delved deep into this numpy stuff, where we looked at one-dimensional arrays, two-dimensional arrays, three-dimensional arrays. Even there was one that asked about four-dimensional arrays in the last class. So we looked at a lot of things as regarding arrays in numpy. Right, so by now you should be comfortable with creating numpy arrays. In your last assignment, I believe you've practiced how to use different functions or methods in NumPy to create arrays, and also the different attributes to get the attributes of your arrays and some information about your arrays. So we also looked at how we can access elements and slice arrays, right? So this was something that you will know already from our regular Python list, right? So we extended it into NumPy and we saw how we can elements in arrays. We can access elements from one-dimensional arrays, and most importantly, from higher dimensional arrays like two-dimensional arrays and three-dimensional arrays. So I believe by now you should have gotten a solid understanding of all of that. So we're not going to waste much time looking at it again. So that was basically what we've done so far. We also looked at some basic operations in NumPy. We looked at element-wise operation in the last class, and I took my time to explain what element-wise operations are. How this is where you want to perform arithmetic operations on each element in an array. All right. So remember, I told us how there are some things that you need to pay attention to, right, when it comes to element-wise operation. But today we're going to look at something called, we're going to start today by looking at array broadcasting, right? So we're going to look at array broadcasting, and then we're going to look at vectorization, all right? So this vectorization is just a concept. We're not necessarily going to, there's no function for vectorization. It's just like the engine behind NumPy array. So we're going to look at it and we're going to help you understand exactly what vectorization is and how it helps in improving performance, NumPy numerical operation performance. So we're now going to move on to look at how we can manipulate our arrays by reshaping our arrays, flattening our arrays, transposing our arrays, joining and splitting our arrays, right? And then we're going to conclude with, we're going to, I think this is second to the last stop, we're going to look at aggregation functions and statistical operations, right? Functions in NumPy that we can use to do stuff, all right, to summarize our arrays and all of that. Then we're going to conclude by looking at some advanced topics like random number generation. And we're going to look at how we can use some other modules in NumPy. Okay, so this is supposed to come. This is supposed to come here. So it's supposed to come here. All right, so hope everyone can hear me loud and clear so I can proceed. All right, great. So today we are going to start with array broadcasting. So what exactly is array broadcasting? So broadcasting is another concept that you need to learn in NumPy. So broadcasting is a powerful mechanism in NumPy that allows arrays with different shapes to be combined in arithmetic operations. Now, this might be conflicting with what we looked at in the last class, because in the last class I told you that there are some shapes that your array has to be of compatible shape to for arithmetic operations or element-wise operations to be performed on them. All right, but now you're hearing that arrays with different shapes. Now there are actually rules that it has to that there are actually rules that it has to meet for this broadcasting to work. So we're going to actually look at those rules, right? But basically what broadcasting is like trying to extend or make two of your arrays compatible so that element-wise operation can be performed, all right? Arithmetic operation can be performed on them. I hope that's clear. So where exactly okay, so now we're going to just breeze over this and then we're going to like demonstrate a little. So broadcasting basically has some rules, right? So for instance, now let's say we have two arrays. We have this array A and array B. Let me just create a file because there's no point. All right, so let me import numpy as np. Okay, so let's assume we have two arrays of different shapes. So for instance, we have this array A, which is array B, which is two-dimensional, and we want to add both of them, right? There are some rules that it has to follow, or there are some criteria it has to meet for broadcasting to take place, right? If those criteria are not met, broadcasting will not take place, and then you get an error. So I'm going to show us exactly how that works. So let's come here and say broadcasting in NumPy. So I'm going to move a little bit fast today because of time. Let's say we have the first array A and np.array. This is going to be a one-dimensional array. Let's say 1, 2, 3, 4. And then we have array B, which is going to be a two-dimensional array. All right, so let's have this. So for the first array, what is our shape? And for the second array, what is our shape? Quickly. I want to be moving with everyone. So we just refresh our memory on what we've done so far. What's the shape of the first array and what's the shape of the second array? The coordinate say print a dot shape and print b dot shape. As you can see, most of us are not getting it. Most of us are not getting it. Okay. I think someone just got it now. This is why it is essential. Okay, I think someone got it. So yeah, the first array is not 1 by 4. The first array is 4 by 1. Remember I told you that like a single dimension consists of rows and no columns. Understand? So this array that we have here now is going to be 4 by 1. So what we are going to have as dimension is actually something like this. 4 by 1. So it's written 4, 1 here, but like if you are to write it in full, it's 4 by 1 intervals and 1 column, right? So not 1 by 4. 1 by 4 will basically mean having 1 row and 4 columns. So I need you to understand that. But the second shape here is straightforward. So the second shape is 2 by 4, having 2 rows and 4 columns. So it's essential that you revise this numpy concept regularly so you don't forget that it doesn't elude you, because it can be elusive, right? So this is the shape of our array here. Let's say you want to perform arithmetic operation. I want to perform like broadcasting arithmetic operation like addition. If I come here and say A plus B, I'm actually going to get an but if you check these arrays, they're not the same thing, they're not the same shape. But at the beginning, when we look at element-wise operation, how element-wise operation work is that each of these elements has to correspond to an element in the other array. I hope that's very clear. So that is basically how element-wise operation happens. But now we are having two arrays with different dimensions. How is it now possible? Which particular element is this one mapped to? Which particular element is this one mapped to, since they are not of the same shape? That is where broadcasting comes in. So broadcasting actually happens on the fly, right? It happens in memory, so you don't usually see it. So it's when you have two differently shaped arrays that broadcasting would come in. So in this case, we have 4 by 1 and 2 by 4. So there is a rule in broadcasting. The first rule is that in broadcasting there are 2 rules, but before we go into the 2 rules, you have to look at the rows in the 2 arrays and also the columns in the 2 arrays. So the numbers on the left hand side, they correspond to the rows, while the numbers on the right hand side corresponds to the columns rather. So the first array here have 4 rows and 1 column, while the second array here have 2 rows and 4 columns. So for this thing to be broadcastable, the array here will be transposed. So we're going to look at transposing like as we move forward in the class. But transposing basically means switching the row and the column. So this thing happens in memory, as I said. It doesn't happen like you don't see it happening, but it happens once you like execute the arithmetic operation. So that is what happened in memory. This one here will come here, and we are going to have something like 1, 4. And then if we come to this one here, we'll still retain 2, 4. Right? So this is the kind of shape, this 1, 4 and 2, 4, that follows broadcasting rule, right? So the first one is like one of them have to match the other, right? One of them, either the rows or the columns, they have to match. So in this case, you can see the column of the first array is 4, and the column of the is 4 as well. So they are matching, which is a good thing, right? So that's the first rule in broadcasting. One of them, either the row or the column have to match each other. That is very, very necessary. And then the second one is that one of them have to be one. Like one of the values here have to be 1, and then the other one can be a higher value than 1. So in this case, we have this particular array having 1 here, and then this second one here having a higher number, right? So it can be 1 or it can be any number basically. So this is kind of shape that your two arrays would need to have for them to be broadcastable. All right. So now just follow me here. Broadcasting is not so straightforward, right? So just follow me here as I just give you more examples, and then you definitely understand it. So, but just use this first example. So this is the first example we're going to be using. 1, 4, 2, 4. Remember that this is not the initial shape. The initial shape of your first array was 4 and 1. But when you execute the operation, this first array, one of the arrays will be transposed, which basically means flipping the row to the column and flipping the column to the row. I'm trying to see if I can get an image that would help you understand it better. So let's see. Okay, so I think I will send that as material later on, so you would have a better understanding. But I was actually going through some resources to see if I would get an illustration explaining broadcasting. But I think after this class, I'm going to send it. Please, class of an assistant, just remind me so I don't forget to send the material. Anyways, the textbook I sent initially had it has this array explanation in it. So if you go through it, you're going to see it as well. So I feel that would even give you more understanding on broadcasting. So let's quickly finish up with this. So in this case, now we have these two arrays, and then we are having the resulting array. The resulting array will always take the higher dimension. So in this case, it's taking the shape of this two-dimensional array. If this was a three-dimensional array, it would take the shape of a three-dimensional array. So the resulting array will always take the shape of the higher dimensional array. So what happened here in this case was that this particular 1, 2, 3, 4 was broadcasted to become something like this. 1, 2, 3, 4, 1, 2, 3, 4. So this is what broadcasting basically means, like extending that particular array to match the shape of this particular array here. So you don't see it, but it happens in memory. So it will broadcast it to become like this. So if you check, if you add this, if you add 1 and 1, you give you 2. If you add 1 and 5, it will give you 6. If you add 2 and 4, it will give you 6. If you add 2 and 4, it will give you 6. So you can see that what happened in broadcasting is that this one-dimensional array was become two-dimensional array, so as to match the shape of this particular thing. But then it will not. This shape that you have here is not going to change. Well, the shape you are going to be seeing is the shape of the original array. But when it is happening in memory, it extends it. So that is what broadcasting is. So it's just a concept, right, that you need to know. It's not something that you can actually implement yourself. It's just a concept that you need to know. So when you are multiplying two arrays of different shapes, broadcasting will take place if a condition, if the criteria is met. So in this case, if we have something like this, if you have something like this array is 1 by 3, yeah, this array is 3 by 1 rather. So if we transpose it to be something like this, 3, we transpose it should be 3 by 1, right? So you can see that in this case, these 3 and 4, they are not matching, right? They are not the same value, so it's not going to work. So if I run this and I come here and I run this, I'm going to get an error. So this one is taking time is because of the error. So I'm going to get an error which basically says that operands could not be broadcast. You can see like the broadcast coming out here, broadcast together with shapes 3 by 1 and 2 by 4. So it is not meeting that particular criteria here that I just explained. So as long as it meets that criteria, it's going to broadcast. But if it doesn't meet that criteria, it is not going to work. So that's basically how broadcasting work. So even before transposing, let's say you don't want to transpose it, there are another way to check if your two arrays meet the criteria is if the values at the diagonal are the same thing. So 3 and 4, they are the diagonal values and they are not the same thing, so it will not work. But if they are the same, if I change this to, let's say, just 3 by 3, I change this to 3 by 3, it's going to work, right? Because now they are the same thing. If I transpose it, it's going to be something like this: 1 by 3, and then what? 3 by 3. So you can see that these values here are the same thing. So you can either use this one to check or you can use this one. But just so I don't get so confused, just use this first one before transposing. Check if the diagonal values are matching. And if they're not matching, then you know that it's not going to work. Even if I increase this my two-dimensional arrays to, let's say, 3 by 3, or let's say even 4 by 4, and I come here to put what's the value is going to be yourself? It's going to be 4. Will this particular operation work, or will it give me an error based on what I just explained? Exactly, it's going to work, right? Because it meets that criteria here. So that is just what you're going to check to know if the broadcasting rule or broadcasting technique will be applied to your particular operation. So if I increase this to 4 now and I run it, so it's now going to be 4 by 3, and that's going to be 4 by 1 and then 4 by 3. So they are not like the same here, the diagonal values. If I run it, it's going to give me an error which says operands could not be broadcast together with shapes 4 by 1 and 4 by 3. So that is basically how broadcasting work in numpy. So there are other examples. I think if I have time, I'm going to give them at the end of the class, but I just want to ensure that we cover everything that I want to cover today. So we move on to the next thing. So, but just keep in mind this particular rule here. Just keep it in mind. If you are multiplying two arrays, you make sure that the diagonal values are the same. The diagonal values are the same. Very, very important. All right. So let's just keep it at that. And you can as well, just quickly, you can as well multiply your array using a scale, something like 3, a single value. So if you have a single value and you want to perform element-wise operation on it, so if you have 3 and you have another array, this 3 is going to be repopulated to become the same dimension as this. So it's going to change from this to something like, it's going to change to something like this. 3, 3, 3. Three, three, three. three, three. Like it's just going to basically extend that scalar to become the same shape as your second array here. If I run this, I'm going to have this. So if you multiply or if you add 3 to each of these elements here, you're going to get this particular value, right? So that's basically how broadcasting works when it comes to scalar value. I hope we're all following up to now. So I'm going to make the attendance, open your attendance. Hope everyone can see me clearly. And you at least understand up to this point. All right, your attendance is open now, so please send your attendance. It's going to close. All right. So let me just write out the rule for broadcasting. You can also apply it to 2-dimension and 3-dimension, but I'm going to just leave that to the end of the class because I'm trying to wrap up with the other concept here. So once we are done, I'm going to give more examples on broadcasting. Since this broadcasting is just a concept, and it's not something you really implement. All right, let's look at vectorization. Vectorization is a concept as well, the same thing as broadcasting, and it refers to the process of applying operations to an entire array instead of looping over individual elements. So vectorization is one important concept in numpy that makes numpy operation very fast. Remember at the beginning when we talked about how numpy is very efficient for numerical operation. The reason for by vectorization allows you to perform these operations at the same time, right? So let's say you want to perform this element-wise operation. You want to add these numbers to these numbers, right? Or you want to add these numbers, you want to add it to a single value, let's say a scalar 6. When you use your normal list, what happens in your normal list is that it goes through a looping process, right? It performs this operation first. When it's done with it, then it goes to the next operation, performs it. When it's done with it, it goes to the next operation, performs it. So it's like a loop. That is how your normal Python perform operation. So when you use loop to perform operation, it's very, very slow. Like it's actually very slow, especially when you have millions of rows, thousands of rows and thousands of columns to like work on, right? But when Python, where vectorization comes in is and when it comes in handy when you have actually that kind of numbers, that amount of large amount of data. So what happens is that instead of performing or looping over these different operations one after the other, it performs the entire operation at the same time, right? So 1 is going to be added to 6 at the same time, 2 is going to be added to 7 at the same time, 3. So it performs it at the same time. So this is because of the nature of how numpy arrays are stored and built. right? Because of some of the stringent rules that are put in place, like making sure that all the data types in a particular array are the same, and some other things, and how it is stored in memory. Remember, I told you that numpy arrays are stored at the same location in memory. So these are the things that enable vectorization to happen. So vectorization makes execution faster by performing operations at the same time on your arrays. So it doesn't loop over the different values to get the final value. So it just happens at the same time. So vectorization refers to the process of applying operations on to the entire arrays instead of looping over individual elements, right? It leverages the underlying C implementation. All these things are just English, so which is basically saying the same thing. So at the end of the whole thing, it will result to a much faster execution. So if you compare an execution of a normal, if you compare the execution of a normal list with values, with integer or float values, to the execution of a numpy array, and you compare the time they perform or complete the execution, you're going to note a significant difference. I think numpy execution is up to, can't really put my hand on their particular value, but it's a whole, it's, I think 100 times, up to 100 times, if I'm not mistaken, faster than your regular Python list, right? So if you check here, you see that we have these examples here. This is a very large array. We are creating a random array of, I think, 1 million values. All right. We are also creating another one of 1 million values. And then we are doing the same thing using your traditional loop. Okay. We are trying to use for loop in this case to perform the same operation. The operation we are performing here is we want to like add these two arrays together, right? So the first approach is using vectorization, which is which, okay, this is the vectorized approach here, which is just adding them together using numpy element-wise operation, and to also use our for loop as well to perform the same operation. You see that the vectorized approach will be way much faster. I don't want to execute this code because it will take a while. So you have the notebook already. What you do is just copy this code and then execute it. Copy this one as well, execute it, and then come here to like run this vectorized approach, right? And then see if they should basically give you the same result. But what you want to check is the time it takes for this particular approach to run, this vectorized approach, and the time it takes for this for loop, normal for loop approach. Take that, doing the same thing. They are adding each of the elements together, right? But they are using different approaches. So just try that yourself and see which one is faster. So obviously, vectorized approach will be much faster because of how vectorization happens. Vectorization allows all the elements or the values in your array to, it applies all the operation on the entire array, on the entire element simultaneously at the same time. So there's no need to go deep into how vectorization happens, right? I just give you some of the reasons why it happens, right? Because of the structure of how arrays are, right? So the structure is a very important reason for the efficiency of arrays, of numpy arrays. So that is it for broadcasting and vectorization. One thing you just have to note, if you didn't get anything from this tree, that these two things are concepts, right? They are like the concept behind how arrays work. I believe I hope we're going to like give some examples when it comes to broadcasting, because broadcasting alone should take a single session, right? If we're going to exhaust everything there, but I just wanted to give you an idea of what broadcasting is. The aim is not to exhaust everything. Right? But if we still have time, and if you have questions as well, just keep it so you can ask, and from the questions we can actually answer some of the questions that others might have too. So these two concepts are very important in numpy broadcasting and vectorization. So broadcasting helps you to perform operations, element-wise operations on arrays with dissimilar shapes, but there are some criteria that has to be met, all right? So, and I explained that already. Vectorization, on the other hand, basically enforces simultaneous operation on an entire array, right, against the regular looping technique that might be used in Python. So an operation way much faster than you would have it, or than you would have it alternatively. So that is it for these two different techniques or concepts. So we're going to now move on to what we call array manipulation. So we've looked at arrays and now we can create them. So like, how do we can we manipulate these arrays? Can we actually change the array? Can we do stuff on the array and just play with it and get some behaviors that we want to get? Is very possible. So we're going to look at some of the manipulation techniques in NumPy. So first off, we have reshaping arrays. We can actually reshape your array. We looked at, showed you this one. So let's just pick them one after the other. So array manipulation is crucial in working with NumPy arrays. It allows you to reshape, transpose, flatten, and split arrays to suit your data processing needs. So depending on what you want to do, you might have let's say a particular shape, but you don't want that particular shape. You want to convert it to a new shape. You can actually reshape your arrays by using a particular function in NumPy. So in NumPy, we have two functions for reshaping arrays. We have np.reshape and we also have np.resize. All right. So let's quickly look at how that works. So let's say array manipulation. All right, so the first one we're going to look at is reshaping our arrays. Let's say we have an array x np.array. Let's just make it of 2 dimension. Let's make it of 1 dimension. Let's start with 1 dimension array. Let's say we have 1, 2, 3, 4, 5, 6, 7, 8. Okay, let's say we have 8 elements here. And if I come here and I check the shape of my array is 8 by 1, so it has 8 rows with 1 column. Now, the way we can apply this reshaping technique is by calling the reshape function on it. So I can come here and say np, you can say x.reshape. Let's see what it does. See that it returns an array containing the same data with a new shape. All right. So we have, you can see that the way I call this is different from the way it was. The way it was in the material is np.reshape. All right. So there are different ways you can call some functions, right? The same function, you can call them by either using np, right? Or you can call them directly using the object itself, right? So the only difference is that the argument would be different. So in this case, if we use np.reshape, we're going to have 2 important arguments. We're going to have, the first argument is going to be the particular array we want to reshape. The second argument is going to now be the new shape. But if I use the object directly, the object in this case is the array. If I use the object, it's just going to take 1 argument, which is, so this is actually one of the thing about Python generally, that you can do one thing in different ways. All right, so you can decide you want to just call the method directly on the object, or you want to call the method directly on NumPy itself. So let's say we use this. If I come here and I say, okay, the shape I have here is what, 8. Let's say I want to change this to become, the shape is here is 8 by 1, right? If I put 8 by 1, it will give me the same thing. All right. So if I put 8 by 1, it's going to give me two, a two-dimensional array where we have 8 rows and 1 column, right? So, but if I think if I remove this, it's just going to give me a single dimensional array with just let's just, yeah, we've been calling it rows. So let's close, right? So as long as you don't put anything here, it's going to remain a single dimension. So, and now there's one rule in reshaping. The sum of your values in this particular bracket has to be equal to, sorry, the product of your values, you have to be equal to the size of your array. Right, so remember when we talked about array size, the array size for this one is 8. So any combination we're going to be putting here has to be equal to 8. The product has to be equal to it. So what are the combinations, number combination that would give us 8? The product of two numbers that will give us 8. So what are some examples of two numbers product that will give us 8? Okay, so we have 2 by 4. Adegbola, we have 4 by 2. Felix, Nigeria, OG, 2 by 4, 8 by 1. No, we don't have 4 by 4 is 16. So you just multiply them. 2 times 4 is 8. So if I come here and say 2 and 4, you see that I'm going to get a newly shaped array. All right. So you can see that it has converted this array that we have here, which is one-dimensional, to two-dimensional just by putting in the desired shape that we want. If I put 4 by 2 here, I'm going to get a different shape. So we're going to have 4 rows and 2 columns. So the main thing is that just make sure that the product of these two values are equal to the size, is equal to the size of your original array. That's the most important thing to note. If I put 8 by 1, 8 by 1, I'm going to get this. I'm going to get 8 rows and 1 column. If I put 1 by 8, 1 by 8, I'm going to get 1 row and 8 columns. So, right, this is how you can actually manipulate your array by reshaping it. So that's it for that. Let me use the np.reshape so you can see how we can achieve the same thing. So in this case, we're going to have 2 arguments. What is going to be the first argument here? Please, we don't have time. We don't have time. What's going to be the first argument here, according to what we've looked at? Okay. So it's going to be array, which is x, then followed by the shape. So in this case, let's say I want 2 by 4. All right. You see that, let me comment. You see that I got the same. So you can see that we can achieve the same thing by using 2 different methods, either calling it on the object itself directly or calling it on numpy itself. So that's it for reshaping. So we can actually reshape different kinds of arrays. Let's say we have 2-dimensional arrays. We have 2-dimensional arrays. Let's just come here and cancel this. So we have this particular array, which is what, 15. All right. So we can Okay, before I move on to that one, let me go back. Okay, so we have this 8 bar. So if I want to convert this one-dimensional array that we have here to two-dimensional array, I'll just put in two values which correspond to rows and columns. But if I want to convert it to three-dimensional arrays, I can actually put an extra value there, which is going to now make it three-dimensional. Yeah, James Jimmy, yeah, exactly. That to get a three-dimensional array, we now put three values here, and the product of those three values have to be equal to our original array. So if I come and I say put 1 here, 2 times 4 is what? 8. 8 times 1 is what? 8. So if I run it, you see that I'm going to get a three-dimensional array. So you can see here I'm having this three-dimensional array, three brackets here, right? So this is basically how we can. So the flexibility is that we can reshape our array to whatever dimension we want. Just make sure that the size of the product of the shape that we want to get should be corresponding to the size of our original array. So let's just try to change this to, let's say, let me even change this to 6, 2 and 6. I'm going to get an error here because where do you want numpy to manufacture value from, right? So it has to use the exact number of values in the original array to get a new array. So if I run this, I'm going to get an error, this particular error, which says cannot reshape array of size 8 into shape 2 and 6, right? Because 2 times 6 is what? 12. All right. So, and we have just 8 values here. So if we want to get this particular shape, where do you expect numpy to generate 6 more 4 more values to make it up to 12? So that's why it is going to give you an error. So you have to ensure that these things correspond. If I make this to be 4 by 2, right? 2 times 4 is what? 8 times 2 is what? 16. So 16 values in total. It's going to give me an error again, which says cannot reshape array size 82 into shape 2 by 4 by 2. So it's very important for you to note this. All right, very, very important. So let's proceed. Let me come in and say size. Let's say I want to like reshape this my array of this size. 4 by 2 by 1. 4 by 2 by 1 will work. Trust me. 4 by 2 by 1, it will work. If I come here and put 4, just make sure that the sum is equal. So in this case now, I'll have 4 blocks. This is the first block here. Second, this is a three-dimensional array. Second block, third block, and last block. The 2 and 1 is the shape of each block. So 2 rows and 1 column for first block, 2 rows and 1. So you understand. So basically, make sure that the sum or the product, not the sum, pay attention, the product, that is, if you multiply all the numbers in that shape, it should be equal to the sum of the size of your original array. That's the rule you should follow when doing this reshaping stuff. Do this one quickly. All right, so let's have this. So now this is an array here. This is a two-dimensional array. I want to like reshape it. So I need someone to give us like 3 possible combinations for. I need one combination for one-dimensional array, one combination for two-dimensional array, and one combination for three-dimensional array for this particular for this particular array here. We want to reshape it to one-dimensional, two-dimensional, and three-dimensional arrays. Exactly. 8 by 8 by 8 by 1 by 1 will work as well. Sunday, yeah, it will work. So I'm waiting for your responses. At this point, you're the one teaching me, so. All right, the first person said 2 by 2 by, that is blessing, 2 by 3 by 2. So let's check. 2 times 3 is what? 6. 6 times 2 is what? 12. So it will work, right? If I run it, you see that it will work. I'm going to get 3-dimensional array of this shape. Let's check another one from the comments. We have 3 by 4 from Felix. 3 by 4. 3 by 4, 3 times 4 is 12, so it should work. So we're going to have 3 by 4, which is exactly the same thing as the original array. So we're not really reshaping it, right? So, but if I have 3 by 4 by 1, it should also work, right? You see, it would actually work. So you can reshape it to any shape you want. Exactly. And click if 12, it should work, right? So it's going to flatten the array to 1 dimension, right? So someone else said 2 by 6 by 1, 2 by 6 by 1. So it's going to give us. So I believe you are now understanding exactly how this thing works, right? So because of time, let's just move on to the next thing. So that is actually okay, since I feel we now have a hang of it. So now let's move on to the next thing. We have another method which does the same thing, resize, right? So now there's a difference between reshape and resize. So reshape will stick with the number of elements, while resize doesn't actually stick to the number of elements. Right? Let me come here and show us what that means. So if I come here and see resize, or let's just quickly check what resize does. np.resize. So what does it do? It returns a new array with a specified shape. If the array is larger than the original array, then the new array is filled with repeated copies of A, right? So this resize differs from a shape in that it doesn't stick with the original size. So let's say I want to resize my array. I want to resize my array to, let me come here. My original array is what? X is what? Let me print out X here. This is X, right? That is X, right? So our X shape is what? Print X dot shape 3 by 4. So let's say I want to resize this to 3 by 5. It's going to work, actually. It's going to work. You can see that we have a new array here, which is 3 by 5, but it doesn't correspond to the original array. What happens is that this particular array is reshaped in a way that we have repeated copies of what we have here already, right? So then the way it does is that it kind of repopulates what we already have so that it can meet the size, the new size that we have. If I come and even say 37, it's going to do it for me. Like it is not restricted by the number of elements in our original array, unlike reshape. So we have two methods now that we've learned. Reshape and resize. Reshape sticks with the original number of elements, that is the size of our original array, while resize doesn't actually stick to it. It kind of replicates or repeats the values that we already have so as to meet with the new size that we want to get. I hope that's clear, right? So let's say I want to have since the shape is 3 by 4, I want to have 20 one-dimensional numbers. You can see that we have everything here, right? You can see we have 1, 2, 3, 4, 5, 4, 3, 2, 8, 4, 3, 2, 1. All right, 3, 2 rather, and then it now starts from the beginning again. 1, 2, 3, 4, 5, 4, 3, 2. So I think you now understand exactly what we mean. Let me make it 24. Well, this 24 basically copies and pastes it. So we have the first one here and we have the second one here. So it repeats the values in the original array and make the size, it just makes the size equal to the new size that we want. It doesn't stick to the original size. So if I want to make this 3-dimensional, I can come and say 4 by 3 by 2. I can put anything there. It will just give me an array. It will definitely give me an array. It's just that it is going to repeat. There's a way it does the repetition. You can see I just illustrated it with that 1-dimensional array here. So it arranges it here for us. So that's basically how we can use resize method for reshaping and resizing our arrays. So the next thing we have here is flattening our arrays. So we have what we call np.flatten. Yeah, it starts from the first element after the last element. Yes, Emmanuel. So np.flatten our array into 1 dimension. So let's come here and let me assign this one to x resized. So I have this x resized here. So it is a 3-dimensional array, right? But I want to just collapse into a 1-dimensional array. So the function to do that is what is np.flatten, or let's just say x resized.flatten. So what it does is that it just flattens the array for us into 1 dimension. It just flattens everything, as you can see here. So regardless of the dimension that it was in before, it's going to flatten it. Yes, Nigeria, resize it to a lower number, it can work. So if I come here and say I want to resize it to 2, it will work. You can see it has just 1 and 2. It will cut off every other thing here. Exactly. Thank you, Emmanuel Arinze. Truncation will happen. To remove every other value and just give. If I say 6, it's going to give me 6, the first 6 values, all right? So it can either remove or add to what we already have, right? So this is what flatten does. It flattens our array to a 1-dimensional array. So regardless of the dimension it is in already, you can just flatten it. So when this flattening actually comes in handy when you are building AI models, right? You have a dimension, like a multidimensional array, and you just want to flatten it. Right, you don't flatten, you can just use np.flatten and then to flatten the whole thing for you, right? Indoors. You also have this particular one, Ravel. So it's like these things are usually they come in 2, but for this particular one, you don't really have any difference, Ravel. So let's see. It does the same thing basically. There is not much difference. So it still return a flattened array. So yeah, that's basically what it does. The same way as flatten. So it returns a copy of the collapsed array in 1 dimension. So for this flatten function, there are some things you can do, but you can try it out yourself. We're not going to look at that yet. There's what we call a parameter called order. You can define the order in which you want to flatten it. You can use C, which means to flatten in your row major or flatten in column major, right? So you can just check it out yourself and try it out. So, but this is basically how you can flatten your arrays. All right. So let's look at the next thing here. We have transposing your arrays. So by now you know what array transposing is. So array transposing or transposing basically means flipping something upside down. So if something is in a certain way, if you transpose it, what you do to it is that you just flip it to be the opposite of what it was initially. So array transposing. Let's say I have this array. Let's say I have x resized this array. Let me just reshape it to. I mean, I already have it. All right. So I have x. All right, I have this particular array here. Let me print it out. And I want to transpose. What transposing does is that it just flip the row to become the column and flip the column to become the row. That's basically what it does, right? If I come in and say x dot transpose, you see that it flipped. Now, this is the original array here, but it flipped it to now become row here and column to be 2. So the shape is 3 by 2 before, but now if you transpose, the shape will now be 2 by 3. Or you can see now 2 by 3. That is basically what transpose does. So you can use this particular transpose method, or you can just say x dot t, capital letter T. So this is a short way of doing transposing in NumPy. Just put T. So no matter what array you are transposing or you want to transpose, once you just do the dot T or transpose function to flip it to become the opposite of what you had, like putting the column in the rows and the rows in the column. So the next one we have here is joining and splitting arrays. All right, so this is where we might become a little bit tricky, but we can actually split our arrays, right? So how do we do that? We can use this for function np.concatenate, np.vstack, np.hstack, and np.split. So there's a good practice that you have to learn when working with Python objects. So let me just put this concat. There's a good practice you have to learn when working with stuff that you don't know about. So once you introduce the new function, you can just come and check them out. Okay, concatenate. Just, you don't need to go to Google. Just do this your question mark. You see what that particular function does. For example, what this function does, it takes arrays, right? And then it takes axis, basically. So these ones, they're really not, they're just optional, right? But it takes in an array. Even if you don't put an axis, by default, it's going to be what? Axis 0. I don't think I've told us what axis 0 is. So in NumPy, axis 0 corresponds to row, while axis 1 corresponds to the column. If you are taking note, I feel you should write that down. Let me see. You can just write it down there. So axis 0 corresponds axis 0 correspond to rows, while axis 1 correspond to columns. All right. No, this is too big. Let me move this header. So this is basically how we work with axis in NumPy. Whenever you see axis 0, just mean you are working on the row. Whenever you see axis 1, just know you are working on the columns, all right? So in this case, when we want to concatenate arrays, we are concatenating by default on the 0 axis. So when you talk about 0 axis, you are talking about from top to bottom. That is a row. The row axis or axis 0 is from top to bottom. So if you are concatenating on the row axis, which is axis 0, you are adding the other array down at the bottom of that other array, right? So that is basically how you concatenate by row. If you are concatenating by column, if you change the axis 0 to 1, then you are adding elements to the side. You are adding more columns to that your particular array. So let's just see how it works. So there are already of examples here, if you can see them. So, but let's basically look at them ourselves. Let's create two arrays. I'll create array AX, which is going to be np.array. Let's say I'm going to a two-dimensional array, right? I'm going to have 3, 4, 5, just a simple stuff. I'm going to have 3, 2, 1. So let's just work with this for now. That's X, right? So I'm going to have Y, and I'm going to have, let me just copy this whole stuff here. I'm going to have 2, 1, 6. I'm going to just change the values, nothing serious. 9. So let's say I want to concatenate these particular arrays together. Concatenation basically means joining for concatenation, joining, NP concatenation or joining of arrays. So how do I do it? I can use my concatenate, my np.concatenate function. I remember what it does. It takes in 2 arrays or more arrays basically. So this dot basically means you can take in more arrays. So we're taking 2 or more arrays and then concatenate them. So as a tuple. So the arrays have to be in a tuple. Yeah. So let's see how we'll do that. So I'll come here and say np.concatenate. So I'm going to put my X and then Y. So if I don't do anything, it's going to give me this. So you can see this one, 3, 4, 5, 3, 2, 1 corresponds to the first one. The 2, 1, 6, 9, 7, 3 correspond to the second one. So you can start it is joining it down bottom of the other array. So that is concatenating on the X axis. That is axis 0. But if I come here and change it to axis equals to 1, you see that it's going to add it to the column by the side. Right? That's basically how you can concatenate. And while you're concatenating, let me just show you something. If I put this and I change it to axis 0, which is by default, it's going to give me an error. Why? If you're concatenating by the 0 axis, the number of columns have to correspond. It's very important. If you're concatenating by the 0 axis, let me write it out here. X axis 0 concatenation number of columns for the arrays must match. If you are concatenating axis 1 concatenation, number of rows for the arrays must match. So this is the rule. Like almost everything we've been doing today, they have rules. So this is the rules for concatenation. So if I concatenate this by axis 1, would it work or not? Exactly. It will work because colon, and for colon, the number of rows must match. The first array has 2 rows, second array has 2 rows. So we don't care about the number of columns each array have. As long as the rows have the same number, it will work. But if you're concatenating by the row, it's going to give us an error, right? So this is just the rule you have to follow when concatenating, all right? So Edith Dion just explained it. Axis 0 corresponds to let me just put it in brackets here. This is for rows, and then this one is columns. So axis 0 is row, axis 1 is column. All right. So that is basically what axis 0 was. If I say axis 0, just now I'm talking about row. If I say axis 1, just now I'm talking about columns. So these are new terminologies you need to know. So what's the next thing here? So we are going to look at a V stack and H stack. So the V stack and H stack, they are still the same thing. They are basically saying the same thing. It's just that in V stack, you are concatenating vertically, which is what? By row. In H stack, you're concatenating by column. So using V stack and H stack. So I told you that in Python, you can have several options to do the same thing, right? All roads what lead to Rome. So you can use different options. So if you forget a particular one, you can always use another one that you can remember. So if I come in and say np.v stack question mark, you can see it's what it stack arrays in sequence vertically, row wise. All right. This is equivalent to concatenation along the first axis after one the array, blah 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 and all of that. So this is how we can use this stack. So if I come here and I just put my two tuple of arrays x and y, it's going to give me an error because the number of columns don't match. All right. But if I change this to H stack, which is column-wise concatenation, it's going to do it for me. So this is basically how you use your H stack and V stack. It's just the same thing as concatenation, but you don't indicate your axis here because by default it is concatenating along a particular axis. But for concatenate method, you have to include the axis. So if you use axis 1, it's just the same thing as doing V stack. If it's axis 0, it's the same thing as doing H stack, right? So that's basically how you concatenate. Now let's look at how you can split your arrays. Splitting your arrays. So the same concept when it comes to this higher dimensional arrays, it still applies whether 3-dimensional arrays. So if you understand how to do the thing on any dimension, you should be able to replicate it on any other. I really spend my time going and looking at other dimensions because of time. So we can also split our arrays in np.split. So if you don't want to concatenate, you want to split, you can actually do that. So how do we? So let's just quickly look at it. So np.split, it will split an array into multiple sub-arrays. So what argument does it take? It takes array, right, which is the number of the array that we want to split it into, the ND array that we actually want to divide basically, and then the indices or section defines the location where you want to split from basically. So we have 3 arguments here. We have the array that you want to split. You have the indices. The indices is like specifying how you want to split it, right? So that is basically what it means. And then the axis, you already know what axis means. Come here and see how it works. So let's say I want to split my X array. So I have to put other positional arguments. So I want to split 1 and 2. So now this is the output of our splitting now. So now what this basically means is that, let me extend this X V. All right, SH. So now we have this, let me print it out, print X. This is our X array here. And by default, when you split, the default axis is what? 0. Axis equals to 0. That is the default axis for splitting. So if you not indicate axis by default, to split on the row axis. So if I say I want to split 1 and 2, what 1 basically mean here is the first index. This 1 is index 1, and then this 2 is index 2 basically. So let's see. Let me just confirm something. NP does split. Results in 2, 3, 3. I just want to confirm something so I don't make a mistake. So we have 1, 2, 3 to 5. Okay, first one is 3. Okay, then we have 5. Okay, great. So now when you are splitting, you have to pay attention to the indices. Now you can see how I use that question mark now to just quickly confirm something. That is how handy it can come in. Maybe you just forgot what a particular thing. You can just come to the notebook, just put your method and then question mark to give you explanation. So this one now basically mean that if you want to have two output basically, right? So this one mean that if from 0, the first one, first indices, let me put first indices, which is 1, first index, which is 1, basically mean, let me put it in bracket here. Basically mean you want your array to be from the beginning to the first index. All right. And the second index here basically mean, which is 2, you want your array, the second split rather, to be from 1 to 2. So this is basically what it means. So you're going to get two output here. So this one here mean this your array here split from split from the beginning to 1, which is this, right? And then split from 1 to 2. So from beginning to 1 is this, and then from 1 to 2 is this, because you can see it as an empty array because there's no 2 second index here. If I come here and I put, let's say 3, I'm going to get this, right? I'm going to get this first split here and this second split here and then this third split here, right? So you can see that there's no second this one should be something like this. I really wish we have more time so I can take my time to break this down. Please, you pardon me, I'm going to like spill over into some minutes. We're going to do a little spill over so we can finish up with this numpy. So I don't want to carry it to next week. So this one is 3, so this one is going to be from 2 to 3. Yeah. All right. So it should be something like this. So let me be sure. Okay. First one 2. Okay, last one 3 to the end. All right. So this one, the last value will always be 3 to the end. So this one will be 2 to 3. This one will have 1 to 2 as well, right? So we have let me just say second split. Second split. then third split. So we should have 4 splits. So now in a situation where you have 3 numbers which are correspond to the indexes, you are going to have 4 splits, right? If you have 2 numbers, you have 3 splits. If you have 1 number, you have 2 splits. So how do NumPy interpret this split? So the first split is what? Let me remove this here. Remove this. Remove this. Remove this. So the first split is from the first index to 1, which is this. Then the second split is from 1 to 2. Then the third split is from 2 to 3. And then the last split is from 3 and from 3 to the last index here. So that is why the second split, the fourth split and the third split here have no values here. All right. So we don't have any values for them here. That's why they're empty. So for the first split and second split, we have this corresponding values here. So that's how we can split our array. So this splitting is a little bit tricky. Like, just have to understand exactly what these indexes mean here. So if you have 2 indexes here, it's going to correspond to 3 splits. If you have, let's say, 1 index, you're going to have this. So let's see. So you can see here that this first one here basically means from this to 0, right? And this second one basically means from 0 to 0 to what here? 2. And this one basically means from 2 to the end. So we have just 3 splits in this case. So the first split is from till this 0 here that we included here. So the reason why we don't have anything for the first split is because, remember I said whenever we are indexing, Python doesn't account for this the number that is at the end of our indexing. So that's why we didn't have any value here. So for the second value, we have 0 to 2, which basically means second index. That's why we have these 2 values. And then the last one, we have this from 2. We don't have any index 2, so that's why we don't have any value here. So that's basically how to interpret the indices or the indexes here when we split. So that's basically it. So remember that this one now, from the first this thing to this first index here, it doesn't take account the first index. Rather, it takes account the index before this index, which is 0, index 0. That's why we have just one this index 0 here, which is this one here for the first split. The second split here is from 1 to 2, right? So which is basically the second index here, which is this 3, 2. And then, so if you understand indexing, you should be able to explain how these splits are happening. That's basically how you can split your arrays in NumPy. So you have the first argument, which is your array that you want to split. You have your second argument, which is the indices, and then you have your last thing, which is by the row. If I change this to 1, it's now going to do the splitting according to column. So you're going to be looking at the indexes according to your column, not according to row again. If I do this, I'm going to get this basically. So you just have to start interpreting what these ones mean here. So I'm not going to do that because of time, but we have explained indexing and all of that. So just use that to understand exactly how we came about all these numbers here. This 3, 3, 4, 2, 5, 1, and 3, 3. All right, so that's how you can split your arrays in NumPy. So understanding this operation is essential for reshaping and manipulating your array. So you we going to use this? How are we going to use this? It's very essential. Like as long as you want to do machine learning, you are going to be working with arrays. You are going to be working with arrays. So if you don't know how to manipulate arrays, it's going to be a problem for you. So all these things that we've looked at so far, ensure that you understand them. You might not understand them now, but just go back, watch the video, practice, and just play around with all of these things. You will definitely get the hang of it. So you don't expect me to just give you every single examples, right? So, but you just need that priming, that initial push, and then from there you can pick it up. So there's some things I introduced you that you need to understand, like axis 0 and axis 1, right? So make sure that you understand which one is axis 0 and which one is axis 1. So let's quickly look at aggregation functions and statistical operations. So this is going to be quick, very, very easy. So remember we looked at arithmetic operation, element-wise operation. So we also have what we call aggregation function. So aggregation functions, they are different in the sense that they don't do the operation on each element, rather they just sum up all the elements or aggregate, that is a better word, all the elements. So these are statistical functions like mean, median, mode, sum, and all of that. So some of the aggregation functions that we have here, we have np.sum, we have np.mean, we have np.minimum, we have np.max, and all of that. So we have np.median, we have np.standard deviation, we have np.variance. So these are the things that some of the techniques you can be using on your numpy array for statistical analysis or data analysis. So for instance, let's bring up this our array here, which is this. Let's say I want to sum up our array. If I say np.sum, it's going to sum up everything. It's going to say 3 plus 1 plus 2 plus 3 plus 3 plus 4 plus 5 plus 3. So it's going to give me the total sum. So this is different from np.add. This is sum is different from add. Add is an element-wise operation. While sum is an aggregation operation. All right. So while both of them perform an operation on the array, they do it differently. Some will add up everything, will aggregate everything. Aggregation is like bringing things together to become one. While add will just perform it elements-wise, right? So just take note so that you don't conflict these two particular things because they sound and they look the same. So you have other things like mean. Let's say I want to get the mean of my array. Let's say x.mean. I'm going to get 3.0. So I think np.mean, if you do np.mean and then you put your array, it's going to give you the same. So I remember that you can use np or you use the array directly, right? So if I say np.standard deviation to give you the standard deviation, I say np.median to give you the median, I say np.variance. So it will calculate statistics with these different functions, all right? So that is how you can perform aggregation. This is just aggregation function, and that's how you can perform aggregation functions on your array. Let's say you want to know the minimum value, the lowest value in your array. You can say np.mean, that is 1. You can say np.max, that's 5, all right? So there are a lot of other things and that you can do, statistical operations, aggregation functions you can perform on your array, and this is just some of them, all right? So that's basically how you use aggregation functions. So there's something I want to quickly show us. I want to introduce you to a new function. It's not related to numpy. It's called round. So round you can use to round up our numbers into a specific decimal place. Let's say I have this particular let me just say standard. So I have this particular x, let me say x standard. I got the standard deviation for x now, but I want to round it up. I don't like how it is like in a lot of decimal, a long decimal place. So the thing is, so we have 1.1118039, but I just want to truncate it or round it up rather, not truncate it. Truncating is like deleting. I want to round it up to 2 decimal place. I can use this round function. So I'll come here and say round, and then put my the value I want to round, which is x standard, and then put the number of decimal place I want to round it to. So let's say I want to round it to 2 decimal place, I will say 2. If I run it, you see that I'm going to get the rounded figure, which is going to be 1.12. It is not truncating it now, it's rounding it up, right? So this is a function that can come in handy. So I can actually add a function inside this x. I can actually enclose this np.standard deviation with a round function. So I just get the rounded figure straight up without having to do the round. So you can see I'm going to get this. If I want to change, I can change it to 3 decimal places. I can change it to 3 decimal places by putting 3 here, and I'll get this 4 decimal places, and so on and so forth, right? So basically that is it. That's in numpy. So the last thing that I just want to show us quickly is generating random numbers. Generating random numbers in numpy. So there's a function, or rather a module in numpy called random. So this is something that is very, very cool. So NP has a module called random. NumPy random module. So this NumPy module is actually like a mini package inside a package. Remember I told you NumPy is a package. So inside NumPy we have other mini packages. So we call those mini packages modules. So we have a module called random. So if you want to like use it, we can just say from NumPy random. So this random now is the module that I want to use. So you can come here and just click on it. If I come here and I say random question mark, you see that it says what the type is, what a module is, a module. So these are the things that you can do, blah blah blah, random stuff. So it will give you a lot of things here that it can do. So if you want to check the functions, you use your dir, and then you see everything here. So these are the things that you can do. So the ones that are common are like the rand ints, random, rand n. All right, so these are the different functions that are inside the random module that you can use to create generate random numbers. So the essence of this random module is to generate random number. So I can import it like this. I can also import it like this. Import numpy as np, and then come here and say np.random. It's still the same thing, right? Because it's still the same thing. So if I come here and say np.random.rand, what it does is that if I check it, it gives us random values in a given shape. So if I come here and I say let's say 3 and 2, okay, it should be 1 rather. So it gives us random values in a given shape. Let's say 3 and 2, right? So it doesn't take 2, we just take integers, rows and column, right? So you can see that it gives us random numbers between 0 and 1. Give us random number between 0 and 1, and I can come here and I say 3, 2, 3. Give us 3 dimensions. This is a way to create arrays too, but random values. Remember the one we created were linspace, which just give us equal distance between 2 values in a confined range. We have ones, np.ones and np.zeros. So those ones just give us ones and zeros, but this np.random.rand gives us random numbers between zeros and 1. We also have another one called random.rn. So this Rn, I think it gives us a normal distribution value. So this is our statistical stuff. So this n, what this n mean here is normal distribution. So the values are normally distributed. So you can see it here. It returns a sample from the standard normal distribution, right? So if you're familiar with statistics, you understand what I'm saying. So I have random.random. So what this does is that it return a random float, blah blah blah, and all of that. So how do we use it? You can come here and just put the size. Let's say 50. It will give you 20 random numbers, right? So I think you can also put shape. Can you put the shape? Let me check. Okay, you can't put the shape. Just so it just give. I think it's the random. You can put shape. All right, so I'm just introducing this to you so you can know that you can generate random numbers in numpy using this random module. You can generate random.int, random integer. This one is like just giving you, let me see, low, high, blah blah blah. Okay, so you can have, let's say, between, you want random integer between 1 and 20, and the size should be 5. So it's going to give you a random number between 1 and 20 is 5. This is just like list space, but the difference is just that list space values are not random. That's it. List space values are not random. They're just equally distanced or equally spaced between the values. So basically, that's just it for today's class. We are actually done with NumPy. So we've looked at a lot today. We've looked at broadcasting. We've looked at vectorization. We've looked at what again? We've looked at array manipulation, how to reshape array, flatten array, transpose arrays, joining and splitting arrays. We've also looked at aggregation functions and statistical operations. We've now concluded with how we can use random module in NumPy to create random values. So just explore these things. Like, I urge you to like practice a lot so that you get a deeper understanding of how to use NumPy. Even if you sit under my teaching consistently for the remainder of this program and you don't practice once, it's better off you don't even come to class at all, because programming has to do with practice. If you don't practice, you won't know. So it's better for you to always practice after each class. If you can't practice along with the class, make sure that as you're watching the video, you practice as well, so that you get and understand. There's some things that I won't even say, that you only learn from practicing. So you say, oh, this thing you can even do it this way, and you can come to the group and just discuss it with your colleagues, like, this is what I discovered and all of that. So so with that, I'm going to be closing the curtain for today's class. If you have any question, I'm just going to take your questions because we're already like past time already. So if you have any question, just raise your hand. All right, Prudence, ask your question, please.
Good evening, sir. Thank you very much for the class. Okay, so I noticed something while I was doing my assignment, my week 4 assignment.
Okay.
So I want to ask, when you open a new notebook and you want to work on it and you do the import numpy as np, then you put it on a new cell. I want to know, that cell where you put it, does it affect the whole cells where you're going to be working on? Or for each cell, you need to keep putting the import numpy as np? Because at some point it was working without it, but I don't know how I felt. I felt like I should ask the question and see
Okay.
if it's something that
Yeah.
affects it.
Yeah, that's a very nice question to ask, actually. The thing is, like, when you open a Jupyter notebook, what you're actually doing is that you are opening an environment, a Python environment, right? So anything you do in that environment, regardless of the cell where it is, this means. So what Python sees is that Python sees everything in the same place, regardless of what. It doesn't sit as cell as you see it. So it's just it was made that way, so we're going to be able to segment our code. So once we do a particular thing in cell 1, automatically in any cell you are going to create, as long as it is in that same environment, that same notebook, it is still going to be connected to it. You are still going to be able to use it. That is why whenever we create a variable in one cell, we can call on the variable in another cell as well. If you define a function in a cell, you can call the function in another cell, right? So it's an environment basically. So what we call it, the terminology we call it is actually namespace. So there's what we call namespace in programming. So everything that you define, every variable, whatever, they are usually pushed to a namespace. So that namespace is what Python looks at in each environment to know whether environment. If you import numpy, regardless of the cell, it's going to be replicated across all the cells till you close that notebook or you close that environment. I hope that's clear.
Yes, it's clear. So I want to know, no, this is just an assignment. Assuming I'm really working on something, and now I'm using just the numpy, and I want to use maybe another function or something, and I want to import it. Can I still import it on the same notebook?
Exactly, yeah, you can import it on the same. Don't worry. By the time we enter pandas next week, you see how all these things work, like how they interact with each other. You can import as many libraries and packages as you want in the same cell. Understand? Yeah, I understand where you're coming from. Don't worry. Just follow. It's going to make a lot more sense to you as we move on.
All right, thank you.
All right, you're welcome. So I think we're just going to call it a day here. Please, if you have any other thing that you want to say, you can just drop it on the group, and do my due diligence to pick it up. So I'm done grading with 2 assignments. So I believe everyone here can see the assignment. If you've not, just give me access to your file, and I'm going to go back to it. So week 3 assignment and week 4, all of them will be made ready before this week, basically. So there's no assignment for this week. Just go and practice everything we've learned so far. All right, I'll send resources. Please, class rep and assistant, remind me to upload this video by tomorrow. If the video is not available by tomorrow, please remind me, and also remind me to upload the previous videos as well. Also remind me to drop resources on broadcasting, right, and vectorization as well. So with that, we're going to call it a day. So do the needful as we've always been doing, and drop what you've learned into this class, on the live class, to help you reflect better and also help others as well. So I usually see some persons posting on LinkedIn. I can't remember the exact name, but I want to give that person kudos. Please keep it up. Keep it up. Like it's a form of visibility, and it also keeps you accountable. It's very nice. So yeah, that's just going to be it. Please let's try to maintain decorum. We are all here to learn. I really want to ensure that you get exactly what you came for in this program. Nobody's against you. Trust me, nobody is antagonistic to you. We are doing our very best to ensure you have the best experience here. All right. So don't assume anything aside from that. I believe we would all work together very well, and we're going to come out from this program better than we came in. So thank you very much for your time, and see you next week on Saturday. And happy Easter, everyone, and enjoy the rest of your weekend. Bye.